This video will introduce the standard form of a linear equation. So standard form looks like this. And the traits would be, it's actually A, B, and C are integers. And then there are varying opinions on this. A lot of textbooks say that A should be positive and then B or C can be positive or negative. And we can adhere to that rule, but if we encounter problems that are set up differently, there's something wrong with it. It's just that some textbooks or some teachers make a universal statement about A remaining positive. And sometimes that just affects the way the equation looks. It doesn't change the line at all, but it can affect the way it looks. But I guess the main trait to take away from this is that A, B, and C are integers. So let's look at the graphing component. The graphing benefit from standard form, it allows you to plot the intercepts. So you can plot the y-intercept, plot the x-intercept, and then they would become the 2 points that you graph from. So knowing where the line hits the x-axis, knowing where it hits the y-axis, that allows you to then figure out the equation for the line, visually see the line, and it's actually a really simple way to graph. But I think it's only beneficial when A and B are actually factors of C, meaning that something like, we'll do some examples. If I had an equation like that, graphing from intercept form would be convenient. If I had something like this, graphing from intercept form could be inconvenient by hand. So here in the first example, I show you that 3 and 2 are factors of 6, and here 7, 2, and 25 are prime to each other, so they have no common factors. So I just feel like that graphing from standard form using the intercepts is most convenient when A, B, and C get along well together as far as factors go, when you're doing this by hand. Okay, let's look at a few of these. And a theorem about slope. If I have, let's go back and think about slope-intercept form. And now let's compare that to standard form. If I isolate the y in standard form, my first step would be to subtract ax from both sides. My next step would be to isolate y, I would need to divide by b. So that means that it's going to look like this. And that's actually a theorem converting standard form into slope-intercept form so that you can identify the slope. So in standard form, the slope is actually negative a over b. And the reason it's negative is because I'm taking this, and my very first move is to subtract ax from both sides, forcing that to be negative. So that's actually a theorem about slope coming from standard form.